Alright guys, so we're going to do questions on set build notation. Alright, so how do you represent your set in set build notation? So always you have to know that set build notation, you always represent your answer in this format. You always say A is equal to X such that X is equal to the nth term. Okay, then you can also describe your N rather, because nth term represents n, isn't it, the number of terms. Where you say maybe you describe what n is, the range for n, or you can say the domain for n. You have to describe the domain for n. So it's always X such that X is equal to the nth term, comma, the domain for n. Okay, let me try answering question A and you're going to understand. But always you have to know that set build notation is always X such that X is equal to the nth term, right? Okay. Alright, so when you're answering, you have to look at, if you want to know the nth term of something, you have to look at the pattern that you have. So the pattern that you have can only fall into three, the pattern of the set. Like if, for example, if you can check A here, this set A is following a certain pattern, right? Now the pattern that you have can only be found in three ways, right? Number one, you have to test for an AP. Now how do you test for an AP? You say second term minus first term has to be equal to third term minus second term. If your pattern falls in this range, then this is an AP. Or you have to check for A2 over A1, which is equal to A3 over A2. If your pattern is following this, then it's a GP. You don't have to worry for an AP. Then if it fails, my friend, then you have to try out common sense. Yeah. So let's check set A before you start thinking. So first term, second term, third term, the way they are. So let's try for an AP first before we go to a GP, or after that we try common sense. Let's check. So A2 minus A1 has to be equal to A3 minus A2, isn't it? So what is our A2? Our A2 is 4 minus 1 has to be equal to 9 minus 4. Now if you can check here, 4 minus 1 is 3, but 9 minus 4 is 5. Now these are not equal to each other, isn't it? So this is not an AP. Okay, so if it is not an AP, let's try out a GP. Okay, let's try out a GP. So a GP is A2 over A1 is equal to A3 over A2. Let's try out 4 over 1 has to be equal to 9 over 4. Now with even common sense, these can never be equal to each other, so it's not also a GP. Okay, so if it's not a GP, let's try using common sense now. So if let's really check now. AP has refused and GP has refused. Let's try out using common sense. So if you can see common sense here is that one, these are like perfect squares. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square. So it's common sense, isn't it? So the nth term, the an, is like n squared, isn't it? Yeah, it's like n squared. So whatever the first term is, if we square it, we're going to have the answer. Whatever the term is, if we square it, we're going to have the pattern, isn't it? So our set build notation for A will be in this format. Will be A is equal to X such that X is equal to the nth term squared, isn't it? Then I said that you have to really write the domain, right? So how do you write the domain on the range of n? Here you have described. So I'm going to say for 1 is less than or equal to n less than or equal to, then you count them. 1, 2, 3, 4, 5. 5. Okay, this is your answer. So you're going to say A is equal to X such that X is equal to n squared, the nth term. Then the domain for 1 is less than or equal to n less than or equal to 5. All right. Let's look at B. All right. So B there, it was supposed to be -7. It was supposed to be in this format. -7, -5, -3, and -1. Right. So let's check out first an AP. Then we go to a GP. If a GP refuses, then we go to the common sense. So an AP is always second term minus first term equal to third term minus second term, isn't it? All right. So what is our second term? Is -5 minus -7 has to be equal to negative